I'm a PhD student at the University of Colorado in the Department of Applied Math.
I'm a PhD student at CU Boulder.
I study applied mathematics at CU Boulder. I came to the University of Colorado without a clear idea of what I want to research, but the diversity and the support of the department has been very helpful in kind of guiding me into a field.
An interdisciplinary approach to applied mathematics is what I looked for in a graduate program, and I was very happy to find it at CU Boulder.
In the United States, there are very few units whose sole teaching and research mission is solely applied mathematics. We are one of those. This autonomy really gives us the ability to train our students basically with the tools and necessary communication skills to work in an interdisciplinary field.
This department really had its renewed foundation, renewed start 1989. The vision was simple: excellence. How do you achieve that? You have to hire excellent faculty. And when you hire excellent faculty, the rest come together.
We have some of the fundamental areas, branches of applied mathematics. This includes computational mathematics, physical applied mathematics, the mathematical biosciences, probability and statistical sciences, and also dynamical systems.
There aren't too many departments around the world that study dynamical systems as a particular specialty, but we're one of the best, I think, that do that.
For me, the best part of the department here is that we are really problem-driven.
One of the major applications of the research in our group is to wastewater treatment. And so what we try to understand are how the differences between individual planktonic bacteria, when they combine together, create aggregates of bacteria that then help us clean the water. And what we really try to understand is the mathematics of that process, how the properties of an individual particle, clump, aggregate, cell combine to create clean water.
Everybody's really eager to incorporate grad students into their research. There are so many different opportunities.
A good example of what kind of experiences graduate students get to have is here in this lab, the Dispersive Hydrodynamics Laboratory, where students will take a mathematical model, perform some analysis on it, do stability analysis, asymptotic analysis, find solutions, and so on. They'll perform numerical simulations of those model equations, and then interpret the results, do some data analysis, but then finally, they get to marry that with the real thing. They get to do an experiment and see what kind of exciting phenomena they predicted, does it really happen? And how well does it agree with their theory? And so it becomes something very tangible and experiential.
Our graduate students and faculty are constantly, vibrantly trying to participate in this sort of state-of-the-art science.
Students get to work with those professors, but in addition to that, they get to take advantage of all those professors' connections to the national labs, NCAR, NIST, Sandia, Lawrence Livermore.
This external focus of the faculty provides students not only good sound training in computational mathematics, but develops a network that will enable their future career.
I work at NIST, which is one of the national labs here, and I do some research in experimental data analysis. So that's one of the many opportunities that people in the applied math department here at CU have to connect with the wider research community in Boulder.
While we may have very long-standing collaborations, it's oftentimes that among graduate students and postdocs, some of the new ideas develop. And that is actually our purpose, is to help the new generation take the helm.
I think that the department has really pushed me, both individually and collaboratively. I've been able to focus a lot on my research, but also my teaching skills.
I was actually a graduate student here and got to leave and go do other things, but I'm so grateful to come back, and I can see how much I benefited from my time here.
It's a little daunting to look back at what I know started the program and how we started it and where we are today. I and my colleagues are very proud of what we've been able to build.
It's a fantastic group of people to work with. We actually all really care about the science, but we also care about the mathematics behind it. So there's always something we can learn, something we can change, something we can tweak. And science isn't always changing, it's always evolving, there's always new things to be discovered. So I think this is a very dynamic environment.
I would say in so-called modern era, we've had 25 years of applied math here at the University of Colorado. We hope to continue in the future that we can train our graduate students with these new mathematical techniques, these new computational techniques that allow them to be leaders in the world, basically. And that said, we would like our department to be recognized as a leader in the applied mathematics, both in the nation and the world.